Hey guys, welcome back. In this video, we're going to work out question 7 of the CXC CSEC March January 2012 paper 2. So question 7 asks, the histogram below shows the distribution of heights of seedlings in a sample. So this is the histogram, and we have on the vertical axis the frequency, that is the number of seedlings with a given height, and on the horizontal axis we have the height in centimeters, right? And each bar represents an interval of height. So the first bar represents the interval of height in centimeters from 1 to 10. The second bar represents the height in centimeters from 10 to 20. The third bar from the second bar from 11 to 20, the third bar from 21 to 30, the fourth bar from 31 to 40, and the fifth bar from 41 to 50. And the first thing we want to do, part A, is copy and complete the frequency table for the data in the sample. So if we look at the bar representing the height in centimeters from 1 to 10 centimeters, that's this bar here, we see that its midpoint is 5.5. That is, we calculate the midpoint by taking the lower part of the range, adding it to the upper part of the range, and dividing by 2, and that would give us the 5.5. Right? The frequency we get by referencing the table. So in this range, that's this here, the frequency is 18, which it is, right? Each tick represents one seedling. Each tick represents one seedling. So here we have 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 seedlings with a height in the range of 1 to 10 centimeters. In the second row, we're looking at the second column in the histogram, and we see that its midpoint is 15.5, and that's calculated by taking the 11, that's the lower part, adding it to 20, that's the upper part of the interval, dividing it by 2, and we get 15.5. So that's this one here. And the frequency is 25, right? Because here we have 20, 21, 22, 23, 24, 25. Right? So there are 25 seedlings with a height in the range of 11 to 20 centimeters. So we do a similar thing for the missing values. So the midpoint here would be, based on the previous calculation, the lower value plus the upper value divided by 2. Here the lower value 31 plus 40 plus the upper value divided by 2, and here the lower value 41 plus 50 divided by 2. Right? And when we do those calculations, let's clear that. When you do those calculations, we get these values here. Right, so 21 plus 30 divided by 2 will give us 25.5. 31 plus 40 divided by 2 would give us 35.5. And 41 plus 50 divided by 2 gives us the 45.5 as the midpoints for those intervals. And then we want to calculate the frequency. So if we look at the 21 to 30 interval, that's this column here. Its frequency is 20, 21, 22, 23. So that's 23 goes here. 31 to 40 interval. If we look at this column, that's 20, and the 41 to 50 interval, that's 14. So it's 23, 20, 14. So let's go back and we get 23, 20, 14. Right, so that completes the table. The next part of the question, part B, determine 1. the modal class interval, 2. the number of seedlings in the sample, 3. the mean height of the seedlings, and 4. the probability that a seedling chosen at random has a height that is greater than 30 centimeters. So let's do part B, part 1, the modal class interval. So let's go back to our table of values that we just calculated, and let's see which one is the modal class interval. So basically the modal class interval is the interval with the most number of seedlings. This interval has 18 seedlings, this one has 25 seedlings, this one has 23 seedlings, this one has 20, and this one has 14 seedlings. So clearly the interval 11 to 20 has the most number of seedlings, and so it is the modal class interval. So the interval 11-20 is the modal class interval. The second part asks the number of seedlings in the sample. Well, the number of seedlings in the sample is the sum of the frequencies, right? So that's 18 plus 25 plus 23 plus 20 plus 14, and so we get 100 seedlings in all. There are 100 seedlings in the sample. The mean height of the seedlings. The mean height of the seedlings is given by first assuming that the height of the seedlings, that the average height of the seedlings in any of the intervals is the midpoint height. If we take that assumption, then the mean or the average height of the seedlings overall is given by taking the midpoint, multiplying by the frequency. Right, so this multiplied by this would give us some number. This multiplied by this will give us some number. This multiplied by this will give us some number, D, E. And when we add those numbers, we would get the mean height of the seedling. So let's when we add those numbers, and we divide by 100, which is the total number of seedlings in all, we would get the average height of the seedlings. So let's do the calculation. 5.5 by 18 is 99. So this is actually equal to 99. 25 by 15.5 is 387.5. 25.5 by 23 is 586.5. 35.5 by 20 is 710, and 45.5 by 14 is 637. And when we add all those up, this plus this plus this plus this plus this, when you add all those up, we get, what do we get? We get 2420 centimeters. And if we want to find the average, then it's that divided by 100, which is 100 is the total number of seedlings. So the average is equal to 2420 divided by 100, which is equal to 24.2 centimeters. That's the average height of the seedlings. And finally, for part 4, we want to calculate the probability that a seedling chosen at random has a height that is greater than 30 centimeters. So let's clear this. Now, if a height has to be greater than 30 centimeters, then it has to lie in either this interval or this interval, because this interval contains height between 31 to 40, so that's greater than 30, or this interval 41 to 50, because these heights are greater than 30 as well. So the number of seedlings that satisfy that criteria is 20 plus 14, which is 34. So we have 34 seedlings with a height that is greater than 30 centimeters. Or if you want to find the probability, we have to find we put the number of outcomes, which is 34, over the total number of possible outcomes, which is 100, and we divide those two, and we divide those two, so we get 34 over 100. So this is this number here represents the number of seedlings with a height that is greater than 100, sorry, with a height that is greater than 30 centimeters, and this here represents the total number of seedlings, which is 100. And so the probability that a seedling chosen at random has a height that is greater than 30 centimeters is equal to 0.34. So let's clear that. If you want to see the actual working for this question, you can check it out at its web page, which is at this location. So this location that shows up here. You go to that location and you'd get the working in written form for this particular question. If you're still confused, send me a comment in the YouTube video or leave a comment on this page, and I'd see how best I can clear up any problems you're having with solving this question. So that's it for now.